Number 5. Just remember, it doesn't work on your phone. You don't have those 3 lines.
All right, so example 5, we're trying to take from f of x equals e to the x, and it's going to go to g of x equals e to the negative 2x. Describe what is happening here. So what is the negative going to do to the graph? It's going to reflect it across which axis? The y-axis. Because remember, your x is going to change signs since it's up there with the x. And the x is positive over here and negative here. So it's going to go across the y-axis. All right, what is a 2 going to do to our graph? Well, is it horizontal or vertical? It's horizontal because it's up with the x. Remember, horizontal always says the opposite, right? All right, so is it a stretch, compression, or a shift?
Compression.
All right, it's going to be a stretch or compression because it's being multiplied. And it's going to be a compression because it's multiplied by 2. So it's a horizontal compression by what number? No, not 2, though.
Negative 2.
1/2. Remember, it's a reciprocal because it does the opposite. And that's really why it's a compression. It's because really it's being multiplied by 1/2. All right, so we have our parent function here. So this is f of x. This is our e to the x. Goes through that point there, which is 0, 1. And then we have our g of x. It's going to reflect across the y-axis. It's a horizontal compression. If I horizontally compress something, so it's from the left and the right, I squish it, what's going to happen? It's going to go up and down, right? Horizontally squish it. Think about it like a water bottle. If you squish it, that water's going to come shooting out the top, right? So this is going to get taller. It's going to get less, where it's not as wide, it's going to get more narrow. So it's going to reflect, and it's going to be more narrow. So it's still going to share that same point. I think I went a little drastic there, so not a big difference in it, but it also reflects. So there's our example 5.